Hey,
Hey,
how you doing?
I'm doing good. How are you?
Doing pretty good.
Awesome. My people are joining.
Great. Hey guys, how's it going?
Well, thank you. How about you?
I'm doing well. Doing well. No complaints. I tried coding this thing up for this workshop really quick, and it was working a second ago, and now it's not working. So I got to figure out what that is before um, we put it in. So that's not great, but it's not really too important, but would be nice.
While we're waiting for some more people to join, if you guys didn't finish working on your rock, paper, scissors, then I would recommend that you continue to work on that. I can put up the continuous instruction for how we can completely finish that code. Let me see. Oh, here we go with Lena.
Looks like 100% sugar.
Hey,
Hey,
Hello.
hi guys. I'm still waiting for people to.
yep.
Yeah.
Nick, do you want to put another reminder out saying it's happening now, or do you want me
Yeah, that sounds good.
to? Okay. Tag everybody.
hmm
Yeah. Happy to see you here, Grant and Cameron.
Thank you. We're happy to see you too.
Two of our newest hires. It's great. Hi, Ophir. How are you?
I'm good. How are you?
Good. Is Jenna joining too today?
She said she might not be able to make it, so it sounds
Oh,
like, just given that she's not here, she probably will not be making it.
Okay. Okay.
Yeah, no, there might be some people in Jenna's room if they didn't see the message,
Mm.
since we had to swap.
How's everyone's morning been? I just went to my first outdoor social gathering. My daughter's friend had just turned 13, so her mom hosted a brunch for us, and it just there were 9 of us, so that was my first time socializing.
Yeah. I had
That's
a
nice.
debate competition this morning.
A what competition?
A debate competition. Yeah.
A big competition?
A debate.
Oh, debate.
Yeah.
Oh, is this through Cal?
Yeah. I'm
Oh,
on the BP team, the British parliamentary team.
That's so cool.
Yeah, I'm hyped. It's fun. It will continue tomorrow.
Oh, good. So, how is it different than an American debate team?
Oh, it's essentially the same thing. The British parliamentary is just a different style. it's like the international style versus an American style, so it's just different styles.
Oh, cool.
Hmm.
How did you decide? Did you join it when you started at Cal?
Yeah, I joined it second semester because first semester I was getting my bearings, especially from remote. And then I found out about it. I was like, oh my God, yay.
Were you involved with debate team in high school?
Yeah, I was for 3 years. So I was
Okay.
like, yes.
And is are there I'm sure there's more than one debate team at Cal, right?
Yeah,
How did you shop around and
Yeah, I looked around. I was interested maybe in mock trial and then maybe in the other styles, but I mainly wanted to continue working on my speaking skills. So that is a more speech oriented debate rather than I speak really fast and cram a lot of policies. Yeah.
great. How many people are in the club?
Like 50, I think.
And your competition today, was it competing with other schools?
Yeah, so it was this is fun because typically we don't get to go to these ones because this one was in UPenn. So it's like
Oh, yeah.
all different colleges from all over. Yeah.
And normally you would have had to travel then, right?
Yeah, normally we would have to travel for that.
I see.
Oh, here we go. Hi, Noe.
Hey, what's good? I was just cleaning my room, so I'm gonna leave my camera off.
Uh-huh.
I'm putting up posters, but I'll be listening.
All right.
Yeah, sorry
Cool.
about that.
Cool. When's your next? And so this competition, Ophir, continues tomorrow?
Yeah, it technically continues to Monday, but I doubt I'll go into semifinals. So
Oh,
yeah.
tell us how it went. What was the
Yeah,
topic?
for sure.
Are you
There are different topics each round. So there's like 8 rounds and there's a different topic for each one. So yeah.
what were some of the topics that you debated
So one of
today?
the topics was like forgery of art should be legalized. So that was an interesting. We always get really interesting topics. It's pretty fun.
That is
Yeah.
interesting.
And then there was another one. Feminism should glorify traditionally feminine characteristics like motherliness,
Oh,
rather than assertiveness. And that was also a very interesting topic. It's very interesting, difficult topics. So, yeah.
are you allowed to choose which side you take?
Random?
My gosh.
Yeah.
Wow.
Yeah. Pretty fun. It's really good practice for public speaking. So I really
Yeah.
like doing that.
Yeah.
Okay. Okay, I think we can get started, and hopefully, if anybody else wants to join, they'll hop on in. All right.
I'm gonna hop off. I'll see you
Yeah.
later.
Bye.
Thanks, guys.
Okay. So let's get started. So last time we kind of finished this off on mid AI for rock, paper, scissors. So we're going to like finish this up today. Just as a quick check-in for everybody, you can either turn on your mic or write in the chat. I don't really care. Were you able to get all the way until like finishing to create the functions? Because remember we had like functions of get player 2 or get player 1 for the MC. And it was like generate the prediction and then create a series of if, elif, else statements that will give us the actual result versus what the player is rolling. Did you guys get a chance to finish that? If not, there's no problem. We can just continue working on it right now.
I did not finish that.
Okay, so yeah, let's just finish that right now then. Okay, so how far along are you in the MC function? Were you able to get the prediction for it or not yet?
What do you mean by MC? I apologize.
So yeah, no problem. So this one is the AI
Oh.
function, the one that like creates the MC player. So the user enters something and then the computer has to play something against it. So this is the MC function. So create.
Okay, yeah, I think I
Yeah.
got that done. Like I did the rock, paper, scissors function, but I didn't do the ML extension of it.
Oh, okay. So yeah, let's get that done then. So if you didn't yet, so create a function called getPlayer1, which is going to be the MC. And we will be using the last two choices we made from the history list. So I think I pasted what it looked like in the chat last time. Let me pull that up as well really quick. So as we said before, if we're drawing from the previous two choices that a user makes, we have to look 2 indexes back in our history. However, you will need to store that in a separate list. So it will look kind of like this. Let me write that on the screen. Okay. Data set equals, I'm making another list. History, I would say, right, -3, then history, -4. Is that how it works? Forgive my brain. No, this has to be -1 and -2. Okay, here we go. So history -2, history -1, the last two indexes on the list, you store that in the data set. And then from this, you want to make a prediction using the model. So what you would do, let's see. I would like to store it in an answer variable. So you would do model. I don't know what you guys named your model, so this could be a bit different, but the essence is the same. And you predict from the data set. And data set needs to go in an extra set of brackets. And then to make sure that you don't get a negative or decimal answer, you want to add this 0 at the end in this brackets like this. This makes sure that it's rounded and positive. So this, I think, was where we stopped last time. Does this ring any bells? Okay, good. So do you guys have this part done yet or no? If not, just do that. Go ahead and do that right now.
So I have this somewhere in my code, but I do not think that my code is organized anything like you want it to be organized. So getPlayer1, getPlayer1 is going to take in a 2-item history list of the histories of the past two choices of the player 2, which is the human,
Right.
and then it's going to give a guess, right?
Okay, so just to clarify, I don't know if you guys remember, but I gave you a history list last time. It was like 4 elements. It was like 3, 2, or 1, 1, 2, 3, something like that. So that history list should probably be in global frame because you want to be able to reference it. Otherwise, you'll have to feed it in as a parameter. You're right. I just like to keep it as a global because it's a bit easier. And then you use that history list to pick out the last 2 choices. So you're essentially saying, so the user did 2, 3 as their last choice. So now using this data, I will predict what they will throw out next. So then because our model is built to take in, for the predict, it's built to take in a list, right, of 2 options. So you do model.predict dataset, and then the 0 at the end that rounds it off. So you don't actually need to take in any other parameters except this one.
Okay, so for now, that history is just going to stay the same list. We're not going to update it.
Not yet. No. We will be updating it, you're right. But for now, it's the same. Yeah, we will need to update it later on.
Could you show me the history list? I might not have it.
Yeah, for sure.
Thank you.
So history list. Actually, I think I may have it. I can send it in the chat maybe. Hold on, let me find it. Here we go. So this is the history list. You definitely want to store that in a global or in a global area or even local, both work. But you'll want to refer to it multiple times. And then do you have the input as well? The input list? If not, I can send it to you as well.
I do.
Okay.
Wait, let me check.
That's the series of nested lists, right? That's like,
Yes.
okay, great.
Yeah, and then you should have an output list as well. That should be like, let's see, 2, 3, 1, 1. And again, I would highly recommend that the input and output list are also global. So all the variables that you'll end up referencing constantly, you will want to make them global, just because it will be easier.
Sorry, what did you say the output list was?
The output list should be, in this context, 2, 3, 1, 1. So if the user throws 1, 1, the next option is 2. If the user throws 1, 2, next option is 3. So that's why we say, I said 2, 3, 1, 1.
Oh, okay.
Mhm.
And what's the method by which we're gonna like the model is gonna make an inference? I don't think was it Ridge and like sklearn and linear model, was it that?
No, it's this
Mm.
time it's going to be, did we get to that part? If we didn't get to that part, then we can definitely go over that again. So the model for this time, because we're using essentially classes of data, because let's say one corresponds to rock, then paper, then scissors. So each output is a class, therefore we're using classification. So the model that we will need is going to be the SVM SVC model. Yeah, and then you can structure that also in global context. You don't need to put that in a function or anything. So you create your model, you fit your data. So there should be a model equals, what was it? SVM, SVC model dot fit somewhere in your data, in your code. Once that's done, then you should have kind of the function for the user that takes in user input, and then we'll get it, and then a function for the MC, which was what we were doing here.
Yeah, so correct me if I'm wrong, Ophir, but the way I think this is working, and this since I missed the last one, I just want to double check. It's a clustering model that we're using, and it's using right? No,
It's classification model.
classification. Yeah, sorry, yeah, classification. But that's yeah, thank you. But yeah, it's a classification model, and the way it's classifying, what it's trying to classify is what they're going to
Mhm.
say and what they're going to choose, and it's making that classification off of the data points of what they've done previously.
Exactly.
So yeah, it's kind of trying to classify what it thinks the decision is going to be based on those data points.
Mhm.
Cool.
So I'm just going to display an example of what your MC function might look like. Let me delete this one over here. I don't want you to copy it exactly because your code may be structured a bit different, but if it looks somewhat like this, you're on the right path. So, sorry, this is using more than 2, so let me fix that up. Okay. So the MC function should look something like this. And then the if statements are so that we can actually return let me present that so we can see that better. Okay, yeah, so the MC function, we want to be able to return the number that would beat the user. So if we predict, for example, I think I did 1 is rock, and then 3 is paper in this example. So again, numbers may not correspond to the numbers you picked. So if the user, if we predicted the user is going to use the number 1 next, then we know that to beat them, we have to get the number 3. So that's just the way it works. And that's why I was like, oh, you probably want an if-else sequence over there at the bottom to return the correct output. And the print answer you probably actually don't need. I'm pretty sure that was for debugging. And then just let me know either by turning on your mic or in the chat when you think you got it.
If we're going to have our models play each other later on, are you using 3 beats 1?
Oh, I will. You don't have to worry about that. I can reformat it to match whatever format we have on there. Yeah, just use your own. Maybe put in a comment what you made each one equal to, and I can just reformat it really quickly.
So now I have a function called getPlayer1 that does something like you show. I have a function called getPlayer2 that just takes user input and returns that. I trained the model on the data that you gave us, and I have history. That's all we need right now, right?
Yes, that's all we need right now.
Thank you. Then I'm done.
Oh, and you should probably have the actual rock paper scissors code from earlier on that was like in the loop. I think most people put it in the loop.
I probably did not do it the same.
Oh, yeah, no problem.
Yeah, I did something.
Okay, yeah, because I remember I made everybody run just regular rock paper scissors code with random computer. Remember that? It's like a random, and yeah, if it judged however much, like the if else statements that it judged. Yeah, if you have that, you're good. You're good. Yeah.
Okay, I think we can. I think I'm.
You think you're good too? Okay, awesome. And then Noe? Yes, no?
Hey, yeah, I haven't finished, but I didn't attend the last one, so I'm hella confused. I just didn't say anything.
Okay. Yeah.
It's okay. Honestly, I could just go watch the last one and come back like 2 times speed, you know?
Go for
And
it.
then come back in 30.
Okay.
Actually, no, it'd be over.
Yeah.
It's tough. I was just trying to like pick it up, but I can't.
Yeah, no, it's gonna be pretty complicated to pick it up from where we are. Okay, so we're gonna soon finish with the rock, paper, scissors, and then we'll move on to a pretty new topic.
Okay.
So if you can like hang on for like 30 minutes, we'll probably
sure.
be done with this.
Cool. Thank you.
Okay.
I'm gonna do my bed.
Yeah,
Thank you.
Sure. Okay. So moving on with this. So we already created the if else statements that handle the function. So this is going to be skipped. Okay, so keep track of your game. I don't know if you guys did this earlier, but it's highly recommended that you just have amount of user wins, amount of computer wins, and draws. I'm pretty sure most people kept track of it. So I'm going to skip this slide. Okay, so create a game loop. So make a game loop that will run your program 10 times. So if you don't have that already, I would recommend that you add that in, because don't run it quite yet, but the next part, it's pretty important that you're writing it in the game loop rather than outside of it. So let me know if you either have it or when you're done.
So all this should do is get the player 2's input and get player 1. Player 1 is the computer, and then say which one won, right?
Yeah, say which one won. Exactly.
Yeah.
And then just run it 10 times. So like either a for loop or a while loop, either one works. Yeah. Do we have that? Do we all have that? Thumbs up, thumbs down? Okay, great. Oh no? Okay, yeah. Take your time with it.
I don't have it, but we can move on.
Are you sure? Okay, because the next part will need to be done in the game loop. So is that good?
I'm just confused. I will pick it up later.
Okay. Yeah, no problem. Okay, so allowing the AI to change over time. Okay, so this was the part where we were talking about earlier, because right now it's just picking up on the list of history we pretty much randomly put in. That's not like a specific pattern that anybody uses. I just made it up. So how might we be able to affect the AI over time? Does anybody actually have any ideas how we might be able to change the result from the AI over time? I actually don't know what that is. Heuristic function? I actually have no idea what that is.
We'll talk about that in the next workshop.
Oh, okay, great.
Yeah, that's something that I'm planning on covering.
Mhm.
And a heuristic function is basically a way to figure out what direction it should be going. But I can't think of, no, I don't know if you have one off the top of your head, or you're thinking of a specific one that might be useful, but I can't think of one that would be useful here.
Me neither, but I just remember
Yeah.
from 61B.
Yeah,
So I was just
yeah.
thinking like, oh, here's the
Yeah,
function.
that's more. Yeah, that's more with like decision trees, which is something else
Yeah.
that we're going to talk about. But that's a
Yeah.
good thought.
The answer is actually a lot simpler than that for sure. Yeah. So this is really okay. How do I say this? Okay, so what is the model even built off of? What is it built off of? What did we feed into the model in order to create it? It should be like on the
Previous
model
choices,
side.
right?
Previous, exactly. We fed in the previous choices. So we had like an input list, we had an output list, and we were like, fit this. Yeah. So we had an input of past decisions, right? But currently past decisions are not updating. How can we update the past decisions as we go through the code? So remember, past decisions are stored in a list.
So we
How
could just
can we,
append
like,
to the list.
yeah, we just
Yeah.
appended the list. Yay. That's exactly it. We just because history list is meant to keep track of our history. So all we have to do is just append new user choices into this example. However, it's not quite that simple because we have to update the input and output as well. So because the model will not, the model needs to be updated as well. So let me show you how that can get done. Okay, so let me pull this up really quickly just so I have, okay. That's not it. Okay, first of all, you probably want to append to the history list no matter what. So go ahead and just write, this goes at the bottom of your game loop. So that's actually really, really important. After you finish checking and you gave the final result of who won, who lost. So before you move on to the next turn, like the very bottom of the for loop, you want to do something like this: history dot append, and then whatever the user's choice was, however you stored it. So that's the first thing you need to do. Okay. Now, we have to also update the input and output list. So remember, input list is in the format of nested lists. So the way we can append to a nested list is just add in or append a nested list of what we want to put in, right? So I would do history, append. Okay, now this is a part that people sometimes struggle with. First of all, add a nested list. Now, we're still referring to the previous two choices, always, previous two choices. So even though we just added one thing to our list, right? We still look back at the previous two choices. So in this scenario, we have to do history -2 and then history -1. -1. So same thing essentially as before, right? History -2, history -1. And this is not for history, sorry, this is for input. Input append. So however you stored your input, you want to append to it in the form of a nested list, the previous history choices. And again, this all goes at the bottom of your game loop. Or actually, wait, hold up. Sorry, there is a better way to do this. So instead of doing -2 and -1, because then you're stuck without having an output. So what you want to do is actually -3, -2, then use your new input, the one that you just put, like if the user rolled a 3, whatever. So you want to add actually to the output. You want to add that to the output. So output, append. This does not need to be nested, so just history -1. So we're using the previous two choices to match that with the user's input to this specific run. And again, this entire thing goes at the bottom of our for loop. Now remember, I did say that if we're changing the input, we have to fit our data again. So if our data isn't fit for this current model, so we just have to do the model.fit again, and just give it input output. Because we modified it, because we modified the input and the output, it's really important to refit it to the data. And that's it for actually updating our data or updating the AI. So this entire thing just goes at the bottom of your game loop. And after writing this in, your AI should be pretty smart. It can get smarter, but this will be pretty smart. So just let me know when you think you got this part done, because that will actually be it for rock, paper, scissors without using pandas. And by the way, if any of you are confused or just need help with decoding, feel free to drop your REPL link in the chat and I can help you out. And again, just when you're done writing the update code, or even if your code doesn't work and you just jot down the update, because that's going to be really, really helpful. So then once you did that, just let me know and we'll be moving on to the big topic for today. And by the way, before we move on to kind of the next topic, Nick is also going to drop some helper code for the competition. We will probably do the competition next time when everybody had a chance to finish up their code and work on it at home if they wanted to. I will
Yeah,
also,
so let me,
yeah,
sorry,
sorry, go ahead.
yeah, I'm just gonna upload it on REPL real fast because I was doing it on my local machine, and then I'll send that. So thanks.
Mhm. So, by the way, just so I can explain it, the purpose of the competition is that you modify the code that we have in order to create a more accurate model. So right now, the model that we are using is using the previous two choices. However, you can either, I don't know, look up patterns that people do in rock, paper, scissors, add it to the history list, kind of do whatever you want with it. Look as far back as you want. And the person with the more accurate model will probably be able to win a prize. So that will also be sort of an incentive to show up next week. Yeah. So definitely take your time to work on it at home if you want. It's pretty fun as well to look for common rock, paper, scissors patterns, in my opinion. So yeah. And then Nick, once you are able to upload it to REPL, yeah.
Yep, thanks. All right, let me just test to make sure there's no bugs. So yeah, there's no. So I also upload the, I'll upload my kind of basic AI that I made for those who are having trouble. Just from following along with last one, I made it. I'm not saying it's like the go-to that you should base everything off of, but just a reference might be helpful for some people. Now, all right.
Okay.
Testing, it's installing all the stuff. I'll go ahead and send the link regardless. And I'll if there's any bugs, I'll fix them. But let me go ahead and send it, and then I'll go over kind of what how the competition is going to work. Whoops, I put it on mine specifically. Let me put it on main, but basically, in order to have the competition, all I want you guys to do, I'm going to go ahead and share my screen real fast. If that's okay with you, Ophir.
Yeah,
All right.
let me go ahead and stop my share screen really quick.
So I just want you guys to make to kind of put your AI in the form of this player object here, this player class. And I gave like some skeleton code here. And if you could just you don't have to put it on the REPL, you can send it to me a little bit before the next workshop. You can just go ahead and like make a file with your AI with your name on it, kind of like I did here with nick.py. And yeah, go ahead and just send it to me. The other two files are a rock, paper, scissors game that you don't have to look at if you don't want, but it can help you. This is the code I'm going to be using for the rock, paper, scissors, so it can help you, figure out how to do it. But all you really need to do is just make sure that, rock is 1, paper is 2, and scissors is 3 when you return. And just make your player have function choice that will give their choice, and a function record opponent choice that will let you update your history. So it'll call this to get your choice, and then it'll give you your opponent's choice after the match. So there'll be rounds of 100, and if you want to test it, there's some just generic testing classes that you can test against. Again, you don't have to use this if you don't want, but it just might be helpful for you. And same with main. Main just has like an example of how to use the testing system, but you don't have to use that either. All I want is just a class with a Python file with your name.py with a my player class in it that has a name, a choice function, and a record opponent choice function. Does that make sense to everyone? So yeah, obviously, we aren't gonna like make you do this or anything. If you don't have the time, then that's fine. But I think it can be pretty helpful to help you understand it, since it is a lot of information to kind of try it out on your own and see how you can improve it. And like Ophir said, it's fun. And we're going to have a $25 first prize, $15 second prize, and $10 third prize. And so, you can to help motivate you. But If you want any help on it, well, obviously not going to give you like direct help in the competition, but if you want any clarifying points, you can come to my office hours, Wednesdays at 6 or Saturdays at 1, or just shoot me any questions that you have. But yeah, does everyone get like kind of what we want in the competition? Cool.
All right, great. Let me go ahead and pull up the something for today. All right. So we are going to be continuing to use classification for today as well, because as I said before, classification is one of the most useful models we will learn. Hopefully we'll have time to go into clustering as well, but we're going to start off with pandas. So that's going to be pretty fun. Okay, pandas. Okay, so everybody should be familiar with the term CSV file by now, but if not, here's a short description. A CSV file is a comma-separated value file. Each line in the file is a data record, so it works just like an Excel file. Pretty sure most of us are familiar with it. Okay, now what is pandas? Oh, by the way, you should probably create a new REPL for this section for today, just because it's good to practice pandas on a separate area because you'll be printing out a lot of stuff. Okay. So short description of what is pandas. Pandas is a Python library that was created for data manipulation and analysis. AI uses it to analyze large volumes of data. So again, as we said, our current AI for classification is using a lot of nested lists, which is nice and all, but it's not really meant for like having thousands of data points, right? So pandas is what we use to make our AI use thousands of data points. Okay, so pandas read CSV. Obviously, from the title of this, you can tell it's probably one of the most important functions. I can send you the documentation link if you're interested, but I kind of summarized it over here. So the main parameter, the name of the file that you want to use. So I didn't give you any files just yet. I will be giving you files. So don't worry about that right now. Just for this part, just look. So what this function essentially does is it returns a 2D array data set, easily accessible to our code with labeled axes. So just as like a brief explanation of pandas and read CSVs, pandas mainly uses dictionaries in order to do this. You can probably write as a coder pretty decent version of pandas on your own. It's not that difficult. It's iterating through a dictionary that's formatted in a specific way. But we don't want to do that because that's a ton of work, so we're using the library. So this formats into linked lists by iterating over a CSV file. So keep in mind, linked lists, dictionaries, two biggest data structures, not linked lists, nested lists that we'll be using in here today. Okay, so the 2D data set. So as we already know, AI in sklearn uses nested lists as spreadsheets. Pandas does something very similar. Each column, so this is a big one, each column is represented by a list within the array, okay? Therefore, when you call the index of a data set, so if I just had a random data set, I don't care what's in there, and I call index 1, it's going to return to me the second column, okay? Is that clear for everybody? Because each nested list, so we're used to nested lists up until now when we converted in our brains between Excel or whatever it was, Google Sheets, right? We're used to it being rows, but this time it's going to be columns, okay? Rows are still accessible, but columns. And there's a good reason for that. I will explain it. So when you call the index of a data set, you're essentially calling for the column stored at that index. Okay, now without actually like looking at the code or any test CSV file, this is just kind of like eyeballing it. I have a spreadsheet with columns ID, num, serial. What will the output data be in this scenario when I call dataset ID? Anybody has any idea of what the output would be? Again, this does not have to be specific. Remember, if we do dataset, read CSV returns to us an array with nested lists, right? So if I call ID, and ID, remember ID is column name. what will output data be?
An array with a bunch of IDs. And
Yeah.
yeah.
Exactly it. It's just going to be a list with the entire column ID in there. That's it. So the reason this is extremely important is because when we do AI, our inputs are always columns, if you noticed that before. So when we were doing like what was it? Wait time for the Disney ride, we had like multiple inputs, right? And we were like using the columns indicated that we are using that input. So this is the big reason why columns are extremely important to be extremely easily accessible in Pandas. Okay, moving on. So drop. Okay, this is an important one. Drop allows us to drop, quite literally, columns, rows, or values from the data set. So parameters, label slash indexes. I will explain what I mean by slash in just a second in the next slide. You will need a list of the labels you want to drop, and then access is optional. Again, you'll see in the next slide exactly why, to indicate whether you want to drop a row or a column. I believe let's go over exactly what that means. Okay, so this is visualizing. Imagine we have this data set over here. Data set or data frame, whatever you want to call it. We have columns A, B, C, D. We have rows 0, 1, 2. Okay, so in this case, we say drop B, C. So in our case, we literally just dropped the columns B, C, like they are no longer in the data set. Why did they drop the columns? Because access is equal to 1. Alternatively, you can do this thing as well. Just make columns equal to the columns you want to drop, and it will result in the exact same thing. Now, if you notice, we're going to have to use the data frame or data set object in order to do this. So you do data frame dot drop, and then in whichever format. Now you can always drop row by index. So in this scenario, we said we want to drop 0 and 1. So we ended up dropping row 0 and row 1. Okay. Does that kind of make sense as like orientation? It's very similar to an Excel sheet or anything like that, except we're accessing it from code. Do we have any questions about this so far? Yes, no, thumbs up, thumbs down. Okay, great. All right, moving on. Okay, so using pandas without CSV. So pandas are not only useful for CSVs, they're useful in general when you're formatting absolutely anything. So we can use a function called data frame. So this will require an import of pandas. So you want to do import pandas as PD. That's why we have PD there. So you want to do D is equal to a dictionary. So remember, this is extremely important. And this example you probably want to do on your own REPL to kind of like visualize what it looks like, especially when it prints out, because that will really help you debug in the future. So D, dictionary, column 1, we have, again, a list of 1, 2. And then column 2, 3, 4. And then we do data frame, and then go ahead and print out DF for yourselves to see what it looks like. Very convenient. And let me know when you're done with this example. And again, feel free to say done in the chat or anything like that to let me know when you're done. Okay, great. All right, so you should be able to see a data set print out. This is very helpful to kind of like know what this looks like. Okay, moving on. Okay, to CSV. So we learned how to get from CSV. Obviously, we also need to CSV. So this is just an example. You don't have to try this out because I didn't actually give you any spreadsheet yet. So this is just an example. We take the data frame. So whatever it was, you still take the data frame. And then you do to CSV. You put the name of the CSV that you want to do. You need to tell it that you need to separate it by comma because that's literally the definition of a CSV, right? Comma separated something file, right? And then index equals false. The index equals false if you don't want to number the rows. That's essentially what it means. Okay, now that we're pretty familiar with this, we're going to move on to the actual exercise for today. So give me just a second, I can pull it up. Okay. All right, so we're going to be using a very common data set actually called the IRIS data set. If you learn classification, you're most likely going to go through this no matter which class you take. So the IRIS data set is an extremely popular data set for learning machine learning technique. Okay, so the data set contains 3 classes. I don't mean like code classes. I mean like classes as in classification that each correspond to a type of iris plant. Each class has 50 data points, and each data point consists of 4 features. The 4 features are sepal length in centimeters, sepal width in centimeters, petal length in centimeters. This is really tongue twister. And then petal width in centimeters. Okay, now that's done. Let's move on. Okay, so I will have you download this on your computer from Kaggle. Let me go ahead and give you the link. Okay. And again, we would be using pandas really heavily over here for obvious reasons. Okay, so this is the IRIS dataset. Go to Kaggle, download the file, unzip it. You should be able to see 2 files, dataset SQLite, and then IRIS CSV. We're only going to be using the IRIS CSV. Let me know once you downloaded and unzipped it. I will show you how we upload it to REPL. Okay, great. And again, just let me know in the chat when you're done. Okay, great. All right. Moving on. So because we're using REPL, if you are used to using PyCharm or Visual Studio Code, probably don't need to do this. But since we're using REPL, you want to go to your file. So you can use the file that you practiced pandas in, no harm done there. Okay, and you want to do, you see the 3 dots up here. Yeah? 3 dots up here, you click upload file, and then you upload your IRIS CSV only. We only care about that one. When you click on the IRIS CSV, you should be seeing exactly this actually. If you're not seeing exactly this, double check that you have the right file. And let me know when you're done with that. Okay, great. Nice. Okay. Moving on. Okay. Step 1, import all your libraries. So you should already have pandas imported as PD because we're using the same file as we did before. And then import sklearn as SVM because again, classes, aka classification. So, and also it's called classification example. So pretty clear what model we should be using here. Okay. So once you do all of your imports, let me know if you need the import of sklearn as SVM, though it should be pretty easily to copy it down. Okay, so this is an easy one, and I will tell you why it's an easy one. What is the first thing we need to do with a CSV file if we're using pandas, aka it was also the first function in pandas that we went over today?
Reading it.
Yes, exactly. So go ahead and write PD, pandas, however you want to do it. Read CSV, and then you feed it the file name. So file name, obviously, this time is iris.csv. And again, don't forget to store it in a data set because if you remember correctly, it gives us a 2D data set that we really need. So very important. And let me know in the chat when you're done with that line of code.
In order to like put it into a data frame, first you would like do read CSV and then you would do pd.dataframe data is equal to the read CSV, right?
So you only need to do dataset equal to pandas.read CSV, and then in the parentheses, you put just the name of the file. The one that was data frame is when you don't have a CSV to read from. So when you do have a CSV, the read CSV does all that for us. We don't need to do that.
Oh, okay. Sounds good. Thank you.
For sure. And again, the really important thing to kind of remember here is while the data set is kind of like nested lists, it's more like a dictionary if you're thinking about calling indexes. The reason for that is we can call columns by their names, like I showed you before when we called ID. So same thing that will happen over here. We're going to call the indexes, aka column names. So input versus output. What is going to be our input, aka columns? Okay, so I really want you to actually look at the data that you see. Let me give you a hint. If you see ID, you should ignore that because ID is just the number row. Because if you see, it's increasing exactly according to the number row. So according to the data and the variables that I went over earlier today when I was saying it's a tongue twister, what should we get as our input in order to be able to accurately predict what type of flower it is? Okay, I just gave away the output, but we should be predicting what type of flower it is. I think that's a bit obvious. So what do you want our input to be? That's a big question.
Sepal and petal measurement.
Exactly. Yeah. So pretty convenient. Okay. So this is a big one. Okay, this is actually something we did not go over because it's not part of pandas. But okay, this is something that I drilled into everybody's heads last time, Noe. So I'll just give you like quick crash course. The computer cannot use math on words. I think that's pretty clear to everybody, right? So if you look at your CSV file, are the flowers in word format or number format? They're in word format. So how inconvenient would it be to go into the CSV file and replace them for numbers for 150 lines? That's super inconvenient. Nobody wants to do that. Like when we're doing rock, paper, scissors, no problem, right? But that's 150 lines. We don't want to do that. So how can we change the species to numbers without going in and rewriting them? So this is called label encoder. I will show you how we can do that. Label encoder is a class. In the label encoder class, we have a function called fit transform, which takes in columns in data frames. So fit transform then fits the columns to encoded label. Hint, hint, it's going to be 0, 1, 2. Yeah, so type 1 is going to be 0, type 2 is good. Type 2 is going to be 1, type 3 is going to be 2. Okay, so here is how we do it. Again, you should, this should take, so fit transform, again, will take in your columns, but here is how you initialize the object. Actually, I don't think I gave you the import for that, so let me go ahead and find that really quick, because you do need the import. Okay. Where are you, import? Actually, you may not need it. I think it may be actually in pandas. Yeah, okay, we're good. Oh, here it is. No, here we go. So sorry, this is an SK, this is part of the sklearn library, but you have to import it in a pretty specific way. So go ahead and import that into your code. And then you just do exactly as you see on here. LE just stands for label encoder. You don't have to call it LE. So LE equals to label encoder. And then you have to LE.fit transform. Yeah. LE.fit transform, and then you feed it the columns that we want to transform. I'm going to leave that up to you to find out what column that is called, because remember we're transforming the flowers. Try to scan the CSV with your eyes and tell me what's the name of the column that we need to label encode. So remember, label encoder is just going to make all of our flowers into coded labels of 0, 1, 2. Yeah, so you should be able to feed it the column name in fit transform. So fit transform. Oh, that gave it away. Okay.
What is label encoder taking in? Or
So for the initialization, it doesn't take in anything. For here, this is literally just what you write. And actually, yeah, okay, so there can be a better order to do this. Just write this line and then we will do the fit transform together. For now, just write this line, forget about finding the species because there is an additional step that will make this easier. Okay, so just let me know once you're done just writing this line down, just the label encoder. Okay. All right, so we're going back to what we discussed just a second ago before we went on to label encoder, which was our date, like the inputs and outputs, okay? So first thing before we actually fit it would be better to do, to define our input and output, okay? Now, remember the slide that I showed you 20 minutes ago about pandas, right? And I gave you, oh, look, I have a CSV that you don't know what it is. And I said ID, right? I was like calling the ID. So this is actually how we call the inputs and output list. So input equals. And now I don't know how you stored the result that you got from the read CSV. So everybody should have a variable that they stored the read CSV in, because obviously it's a data set. For me, when I wrote it, I just called it data set. And again, because nested lists, yay, so important. Okay, what you need to do is the following. You need to list the names of all the columns that you want to use, like this. And you will need to do the same for the output. So it would be like, output is pretty easy. You should have figured it out. You should. I hope you saw that the output is called species of flowers. If not, I kind of spoiled it. So output value equal data set species. Let me make this bigger. This is pretty clear. But for the input, you should just be listing the columns that you want to be using. So there should be like 4 values, like another one here, another one after that, etc., etc. Ah, that deleted. Oops, here we go. By the way, the way you write it, so species has to be with a capital letter S. That's because that's just the way the name of the column is written. So again, imagine each column is like a key in a dictionary. And then let me know in the chat once you think you're done with that. Okay. All right. Now we can do the fit transform a bit better. Okay. So since we're only encoding the Y or output values, doesn't matter what you call them, we are calling LE, aka label encoder, dot fit transform, because we need to transform this. And then the Y, so Y is just the output. This is just my output values. Yeah. And then you just call species like you would call it earlier, like this. So the Y encoded is going to be what we will be using actually instead of the previous output. You will see this in a second. Because again, models cannot read words. They'll have to read numbers. So let me know once you're done with this line. Again, just make sure that you're matching it to whatever variable names you used. And I do recommend that you call it either output encoded, Y encoded, whatever you want to call it. But the word encoded would be pretty helpful for you when you're looking over your code again. And again, just let me know in the chat when you think you're done with that. Okay, great. Everybody's done. All right. Moving on. So now we actually have everything we need in order to do the model fit and all of our model stuff. So model, store your model in a variable and then fit it to the data. So I just realized that the name I put here is pretty long, iris prediction model. You can just write model. I'm not gonna hunt you down for that. And then you just do fit. So fit, again, this is just a regular input, but pay close attention that we're using Y encoded here. Again, because you don't want to feed it words, it will error out for sure. Yeah. So go ahead and do that. And then Noe, just quick crash course on what this is. We just create a model, like a mathematical model. This is the SVM SVC. And then we have to fit our data to it using the input and output. So yeah. And again, just say in the chat when you think you're done. Okay, great. Nice. Okay, moving on. Oh, is that my last slide? Yeah, so, no. Yeah, I knew that was not the last slide. I was like, okay, great. So our output at the moment would still be a number. So we need to inverse transform the output. This is a big one, right? If your user, I don't know, if you're working in some big shot company and you wrote an AI and you have like millions of possible outputs and you give your user a million, I don't know, 5,569, I don't know. Yeah, they're gonna be like, what the heck does this mean, right? Like that, I didn't ask for a number, I asked for a classification. Like what flower is this, right? So we're going to have to inverse transform. Okay, that's a big one. So first of all, go ahead and use this prediction. So prediction equal iris prediction model or whatever you called it, dot predict. Feel free to use these numbers, feel free to use different numbers. This numbers will make sure that we can all check if your output is correct. So yeah, this is good numbers to use. So then print prediction, you don't actually have to print it. I'm telling you it's a number. Okay, so then we have to return it to original. So you use the label encoder dot inverse transform, you feed it the prediction and it will return to you the original. And that one you do want to print. So go ahead and do that. And again, don't forget to let me know when you're done with that. And by the way, feel free to write what you got in the chat. I'm curious. I don't remember what this is actually supposed to give, what type of iris it is. Oh, to install dependencies? Really? Oh no. Man, REPL sometimes is just so annoying.
For
Yeah.
real. Remember that one time with
Oh my god, we had to, Noe and I taught BUSD class together, and there was this one person that for some reason REPL at a certain graphics level did not work on their computer whatsoever. It was great. And we had to explain to them why their code worked, but they couldn't see that it worked. Pretty sad.
yeah.
Satosa. Yeah. Cool.
Same.
Okay. All right, Iris Satosa. Final prediction. Okay. So this is a pretty fun model because I'm pretty sure the data is 100% accurate. So, if you're ever out there in the wild and you're like, oh, what type of iris this is, just take out a ruler and be like, yay, let's figure this out. Yeah. Okay. So let us move on to the next one. All right. Now, we have learned two big models until now, or two big ideas until now. Both of them, you may actually be familiar with this because in research papers, they refer to these two terms a lot. Supervised versus unsupervised learning models. Like, I know when I research AI, those two things are the first things that pop up when you look at any research paper. Supervised learning models predict approximation of the output. So think linear regression. So this is a really big one. When there is an output present, like when you physically feed it an output, you know it's a supervised learning model. In unsupervised learning models, we use the inputs within the data to predict the output, even if we don't know the output ahead of time. So this is a bit of a thing to wrap your head around. So I have some neat diagrams for us to look at. Okay, the big unsupervised learning model that we will be learning is called clustering. Okay, now here is what we have. This is the best example I can think of what unsupervised or not knowing the data ahead of time looks like. So as you can clearly see over here, we just have some random data that clustered itself. Like, we can visually see that it is clustering, right? So I can call this cluster 1, cluster 2, cluster 3. Yeah, these are the outputs that I decided for myself. I didn't say necessarily that these are the correct outputs, but it's pretty clear, I think, that the clusters are bunching up together, right? So in this scenario, we know only the input, but we are able to predict the output. This is unsupervised. Let's see another model. So what is the natural grouping among these objects? So Simpson's family, school employees, females or males, all of them are correct clustering. There are multiple clusterings I could use here. If you've ever done stats or statistics of any form, this is extremely prevalent because you're just looking at the data. You don't actually know if it's the truth, but you have to kind of make conclusions from the data. So this is what clustering is for. And there is a big reason, as you can probably see, why we cannot do it without pandas or some form of graphing. Okay, so what would be the clusters here? Anybody want to draw a line for me? Draw some clusters on my screen. Yeah, exactly. We can tell with our naked eye in this example, but we won't necessarily be able to in all of examples, right? And this is AI because this is pretty great for AI, right? So yeah, exactly like Noe drew it. So K means clustering. This is the model that we will be using. It's going to be a bit different from what we're used to until now because, again, we don't have outputs, which is like a big issue in the regular model that we just learned, like anything regression or classification. K generally stands for the amount of clusters we want in the data. So for this example, without looking at this, yeah, there actually could be more than 4 clusters. I could say that this is a cluster, then this over here is a cluster, then here, then here, and then up here. I could say that, right? This is entirely possible from looking at the data. Again, this is more like a stats rather than, I don't know, like real, not real, math that we're used to, right? So because you don't know the output. But I told my data ahead of time that I'm going to want 4 clusters. So it drew for me 4 clusters and very clearly drew it. And yes, they do color code it pretty much immediately for you, which is really nice because very visual. Okay. Okay. So this is just a fun exercise. Think about your life, much like The Simpsons. Select a group of elements and divide them into 2 to 3 groups. Name the groups. You don't actually have to do this. It's a mental exercise. But yeah, if you want to, please do. Yeah. Okay, moving on. So you don't actually have to read that. I will explain this. Okay. So in here, we're going to have to import a new library. It's going to be pretty fun. You probably want to start new code for this one, and I will send you the import in the chat. And we will still be using the Iris CSV because it's pretty great practice. So in whatever new code that you're doing, make sure you also upload the Iris CSV. So we're going to be using PyPlot. I don't know if you guys like Java or Python more, but this is a huge reason why I love Python because there's literally a library for everything and it's all pretty easy to use once you read the documentation. So yeah. So make sure you're importing matplot matplotlib.pyplot as PLT because you don't want to have to write that entire statement every time. And again, you want to import pandas, obviously. You are also going to want to import the label processing and the scalar and SVM that we used earlier. Or actually not the SVM, hold up. Let me find exactly what you want to import. Here we go. This is the one you want to import. So we're going to be using a completely different model than we used until now. From sklearn.cluster, import k-means. And we will be using the k-means model. Let me know when you got that. Okay. Looks like most everybody is done. So actually, I'm gonna ask you to copy paste a lot of code. So you probably want to copy paste everything that we had in Iris from all the way to the label encoding. So all the way until Y encoded, you want to put that in because pretty convenient. So we don't have to rewrite it. Okay. once you're done with that, let me show you what we are going to want to do. So again, you just copy, we didn't even actually create our model yet, nothing yet. So far, we only have the stuff that we have from our iris until that Y encoded area. So here's a big reason why clustering is a bit more difficult. We want to actually draw the scatter plot ahead of time, because just like we did earlier, right? We had a scatter plot in front of us, then we drew the boundaries. So we have to go in that order. Okay, so plt.scatter will draw the scatter plot for us, okay? Then we have X, and again, okay, so here's a big one for this one. Let's see. So before this, actually no, just leave your input or your X however you want. But we will only be using 2 of the columns this time rather than all 4 of them. Reason being, we are not graphing in 4 dimensions. We will be graphing in 2 dimensions. So we are going to want a very clear X and Y axis in order to be able to visualize this nicely. So you do have to do this in this exact format. You don't have to do sepal lengths, you don't have to do sepal lengths, sepal widths. You can do whatever the heck you want. Some will be more accurate than others. So if you find the more accurate one, yes, that's good. Yeah, so there are more accurate pairs. I don't remember off the top of my head which they are, but I can check. Yeah, and then you do want to have the C in there. This is just formatting. Y encoded, and then CMAP. There are multiple themes that you can use, but just Rainbow is just one that I like. I can give you a couple other options. I don't remember them, but I can look for them. And then again, for the X label, Y label, we're not really doing anything too special. This is just setting the font, because I don't know if your math teacher did this, but my math teacher drilled that if you don't label your axes, you're getting a 0 on the problem. So we're gonna have to label the axes. Yeah, and then you want to save the figure to plot PNG. You don't actually have to call this plot PNG. This is just the name that I picked. You are free to name it whatever you want. So let me know once you're done with that. And after you run this, you should be seeing a plot saved in your side area. And it will be color coded, but not correctly. And you'll probably be able to tell that it's not color coded correctly. But yeah, let me know once you're done with that.
I'm getting a pretty ugly error, and I'm not really sure.
Can you send me your share link? I can take a quick look at that.
Yeah, thank you.
Mm-hmm. Okay, thank you. Let me take a look. Okay, IRCC label encoder. Oh, you called it flowers. Okay. Coded. Ah, I think I know why. Okay, so wait, actually, wait, hold up. Why is it? Okay, it may be. No, that should work on its own. Hold on, give me just 1 second. I'll take a look at the code that I prepared. No, that should be fine. Does this work for everybody else? Just making sure. Because if it's an error in the code that I gave you on the screen, then it shouldn't work for anybody else. Is everybody else able to see the plot pop up? Yeah? Okay, so then it's not wrong in the code that I gave you. Just making sure. Okay, let's see. I'll probably have to fork it. Okay, let's see that.
Okay, send it to me as well. Thanks.
Yeah, no worries. If we need, we can just move on and
Oh wait, no, I know what's up. Hold up. So for your input flowers, you put each name in separate lists. They should all just be in one nested list. So it should look like this. Hold up. Okay. People like this. Here we go. You have them each in like a separate bracket. Yeah.
okay, I'll rerun it. Thank you. I
Yeah.
appreciate
Oh, and your output, sorry, your output as well. Your output for flowers, there needs to be like a double bracket there as well.
Okay, thank
Mhm.
you.
Yeah, no problem. Okay. So I'll just show you what the next line of code after you're done with the whole plot is gonna be. So everybody do it at your time. So what we're going to do, we're going to create a model, right? So KM, you can just call this model if you want to keep it uniform. And then you do k-means because that's exactly how we import it. Now we know that we have 3 clusters. Sometimes you won't know if we have 3 clusters, but this is, in this example we do. This may not be the optimal data set, honestly, for this type of prediction, but it's good practice because we know ahead of time. And then you don't want any random states or anything like that, so keep that to 0. And then just n clusters equals 3. And after that, obviously, like we always do, you do model.fit. And you fit in, no, this time, because again, remember, clustering doesn't have an output. We only put in the input. Yeah. So big difference, honestly, from the classification. Oh, does it, man? Hold up. Oh, I think it, hold up. caused an error. Yeah. Okay. And let me know when you guys are done with this step because the graph shouldn't change just yet. Okay. Okay, if everybody's done, then let me pull up one more thing that I really want to go over. Okay. So before we do anything, so right now you should still only see one graph. Why is that? Well, we didn't create a second graph. So we actually have to create the second graph in order to be able to see the difference. However, we still need to label encode here, okay? Because obviously, okay. So labels is actually an attribute. It will look like this with the underscore. It's a bit weird, honestly. So to create new labels, you do new labels equals KM or whatever you named your model dot labels with the underscore. So then use new labels in our implementation for PLT scatter instead of the original Y encoded. So the reason this is mainly because of KM formatting. It's not like anything super special like the label encoder was, because yeah, this is just specific labels that will be fit to the specific model that we're using. So go ahead and write this line of code as well. And then you want to repeat the exact same steps that we used to create the previous scatter plot, except name it something different and replace the Y encoded with new labels. So you can essentially copy paste the original lines and then just put it in there. And then after that, you'll be able to see two graphs, pretty nicely colored. Yeah. Let me know when you got that. Okay, everybody seems to be done with that. Are you able to see two graphs pop up? There should be a pretty clear difference in the coloring of both. So make sure that that's a thing, because sometimes people have like small errors that cause the graphs to be exactly the same. If they're exactly the same, color coding wise, then something may be wrong. Okay. Other than that, that is it for that exercise. Do we have enough time to do another exercise? We may. Hold up. Actually, so this is pretty fun because I think there's a pretty big difference in the graphs for that. I want to give you kind of like the rest of the class because that was about it for the models that I will be teaching you until next time. But something that I made students who learn this do for fun is to find the pair that has the highest, the best clear ratio of what to predict from. You'll be able to see it on the graph, right? Because you can tell when the clusters are very clearly defined versus when they're not. In this specific, if you use what I use, like the steeple width, steeple length, then it's actually not very clearly defined. So if you want to look for more clearly defined ones, that's a pretty fun exercise. And if not, then if you didn't finish yet, continue working on your rock, paper, scissors one, because that's for the next week's competition. Because we don't really have much time to go over anything new. Yeah.
Okay, so I want to ask while y'all are working. Well, first of all, do you guys have any questions about anything that we've done for the past 2 workshops here? Because the next one is going to be building on this, but also kind of some different material. And I also wanted to ask what you guys are interested in learning for the next workshop, because I have stuff that I can talk about if nobody has anything in particular. But if there's something that was confusing or interesting about what we've learned so far, that you want to hear more about, then we can talk about that now, or we can talk about that in the next workshop, or we can just do whatever else you guys are interested in. So yeah, so first of all, do you guys have any questions about what we did today? Or is everything working out for you? Cool. Yeah, and then do you guys have anything in particular, like when you decided to take the AI workshop, or when we talked about it, you're saying, hey, I hope they covered this, and then we haven't covered it yet, or something that we have covered that you want to know more about? No? Okay, cool. So on that note, I did want to also ask, is one thing I think is super cool is like search algorithms, decision trees, and all that, which I find really interesting, and I'd like to cover it. But I know it is covered in some things like Noah, you said 61B, it covers it, and all that. So I just want to ask you guys, do you guys already know all that stuff? Like, you feel like you already have a pretty good understanding of the basics of it and don't think you would really learn much? Because if so, I'll just skip it. But if you think that it could be interesting, like, for example, making like a tic-tac-toe AI that can play it perfectly using a like Minimax decision tree. I think that was literally done in CS61B, honestly. But I think it's a cool thing to teach students, and I think it's a cool project. So if yeah, oh, no, it was that. Okay, you're cool to review. All right, cool. Yeah, so I'll cover that, and then probably talk about how it fits into reinforcement learning and stuff like that. So great. So yeah, nobody has any input on what they want to have in the next workshop. That's totally fine by me. That means I get to choose. But I think it'll be more interesting if you guys, to make sure that we do cover what you guys came here wanting to know about. So awesome. Cool. So yeah, with that, unless Sophia, you want us to have them keep working, I think we can actually probably just finish it there if nobody has any questions. Finish this one a little early. Yeah, if you guys are interested in trying to improve your rock, paper, scissors AI, then like I said, you can message me or come to my office hours, and I can help kind of explain anything that you might not be getting. Yeah. So if not, then I will see y'all next week.
Yeah. See you guys.
Thank you guys for putting in the time for this.
Thank you for coming.
Appreciate it. Yeah.
Mhm.
All right, see ya.
See ya.